Okay, Assalamualaikum and hello students. Okay, so in this video, I want to tell you how actually can come up with the result and also discussion for the practical under actually under title measuring the conductivity for the strong electrolyte. Yeah? So if you look at for the objective for this practical is that to relate the between the conductivity and also concentration of various electrolyte, and also to measure the conductivities at infinite solution, and last to measure the activity coefficients of the electrolytes at the different concentrations. Okay, let's begin first with this result. Okay, so what you need to have in your result first actually is a table showing that the calculations on how usually you get the mass for the each of the compounds. So since you have 4 different electrolytes, so saya nak actually basically in the table, so you actually shows mass actually required to prepare 0.1 molar stock solution for the all 4 electrolytes. Okay, so in the next table, so this will be the volume needed for the dilutions. Okay, so how much of the volume needed for you to dilute from the stock solution for 0.1 molar to 0.045 and dilute to 0.01 molar, 0.05 and so on lah basically. So this table will be applicable for the all type of electrolyte, akan samalah sahaja. So I need you to come up only one table. You can have this actually to basically one table to represent for the 4 different type of electrolytes. Okay, so now comes for this your data. So for this actually project, so this practical, so you need to measure the conductivity for different electrolyte at the different concentrations. So what I need you to come up with the third table, which is the conductivity. Okay, so first in the first column showing the showing the concentration. Okay, let's begin with this table for the NaCl. Okay, so for NaCl, so you have a first column concentrations, you have a stock solution 0.01 molar, 0.05, and then after that in next column you can square root of the concentrations. Okay, and then after that you can have this reading for the conductivity that you use the conductivity cells to measure for each concentrations. You have A, B, C, and this will be the average lah. Okay, so you average it. Okay, don't forget to put the unit for the conductivity. So depending on the instrument, the cells that you measured, let's say use the millisiemens per centimeter, then you have to put this millisiemens per centimeter. But if you want to come with the microsiemens per centimeter also doesn't matter. Tapi yang penting you kena put the unit lah, whatever come up. And this conductivity dia punya symbol would be kappa, so K here. Okay, so kappa. And in the next column, so you need to come up with this molar conductivity. Okay, so how do you measure the molar conductivity? So you know that molar conductivity is equal to conductivity, which is kappa divided by the concentrations. Okay, so this actually conductivity for the average one. So you have get here, and then you need to divide by, you have a D, you divide by 0.01 molar. So 0.1 molar. Okay, so this is the calculations lah. You can see here is that okay, so you can see here for this actually concentrations, you know that 1 molar is equal to mole per dm cube. So since that the unit in the conductivity is centimeter, so you have to convert this dm cube into centimeter cube lah, per centimeter cube. So what you can do is 0.05 molar ataupun whatever concentration you have to times with 1 times negative 3 to get your value would be in mole per centimeter cube. Then you can plug in into these equations. Okay, then have to complete all these molar conductivity table or column. You divide by all the concentrations. Okay, and then in the last column, you have the equivalent conductivity. Okay, so how can you determine the equivalent conductivity? Okay, so this would be the formula. So you have here is that equivalent conductivity is equal to 1 over n times with here would be Z would be the charge times with this molar conductivity. Okay, for examples, I have aluminum sulfate. You know they have a 2, you're producing the 2 Al3A plus, and this one 3 SO4 2 minus. So the molar equivalent conductivity is equal to 1 over what be the N here is 2 times with 3. Okay, then we times with the molar conductivity for these concentrations lah. Then you can get this column for then you can need to fill in of these informations lah is equivalent conductivity. Okay, so this actually you need to have the complete table. So this is for NaCl. You need to also to come with the another 3 type of electrolyte with a different concentration, with different conductivity, and also with difference with the molar conductivity and also equivalent conductivity for the each of the electrolyte. Okay, so now moving on this okay, so this is like here. Okay, how you can measure. Okay, so now you need to come up with the table. So the table you have to come up first would be the conductivity against the concentrations. Okay, if you look at here, and this actually this conductivity against the concentration. Okay, for NaCl, so means that for this table, this only for NaCl. Okay, so you have this the different concentration, and then you need to have another 4 type of graph for different 3 electrolytes, and another tables you need to have here would be is a molar conductivity. Okay, against is a square root of the concentration. So based on this table, so you have to plot this against this one. Alright, so for this table, okay, you have this actually molar conductivity against concentration for NaCl. You can also have the another electrolyte. So here would be CaCl2 and also N2SO4, okay, and so on. Okay, then can have 4 electrolyte in one graph. Oh, sorry about this one. This one also same lah. So you have one graph. You have also 4 lines lah. Basically, you will have 4 lines for different electrolyte. Okay. So next what you need to do is you need to discuss what would be how can you actually see when we have the different type of electrolyte. So you know that in NaCl you have a 1,1 electrolyte. This one you have a 1,2 electrolyte, and you have this one you have 2,1 electrolyte. Okay, so you see here what would be the trend for the conductivity. Okay, when you have the 1,1, 1,2, 2,1, and discuss and see and also discuss in terms of concentrations, whether the concentrations actually will give the higher conductivity when you have this higher concentration, higher conductivity, or lower conductivity. This is the thing that you have to discuss and save with the molar conductivity. Alright, so now this actually, if you look at for the objective, so this would be the relationship. And how about the conductivity at infinite solutions? Alright, so this actually conductivity at infinite solution you can get from this. You can determine conductivity from this table. So here, if you look at for the equations, we have this which is here minus with the C, and it will be these remember mx lah. So basically the slope, so based on this actually we'll have the straight line. Okay, so you have y equal to mx plus c. So based on this electrolyte, you can determine of this actually conductivity at infinite solution by looking at the intercept lah, which will be the c. Boleh tentukan based on, let's say you have the graph here. So what would be like when c is approaching 0, what would be this conductivity at infinite dilutions. Okay, so you can determine based on the different electrolyte, and after that you discuss, okay, what actually you will see the value from the different type of electrolytes. Okay, so now we go to the third objective. So the activity coefficient. So how can you determine the activity coefficients? So this one actually has been discussed actually in the lectures. You know that by using the Debye-Huckel-Limiting's law, you have here is log negative A Z plus Z minus for the I squared. So using of these equations, you can determine the activity coefficients. So you need to calculate the activity coefficients for, let's start with the NaCl. So you have a 0.1 molar. So first thing, in order for you to identify these activity coefficients, you kena tentukanlah the ionic strength. So first calculate the ionic strength. So ionic strength is half equal to m squared z squared plus with m minus. Okay, so this is 401 molar. So you can determine here what be the ionic strength, then plug into these equations. And this Z plus Z minus, this will be the plus 1 minus 1, and this will be the constant, which is A would be 0.509. Then you can determine the activity coefficients for 0.1 molar of NaCl. Then what you need to do is you need to come up with the tables. You have this NaCl. Okay, you write down the concentrations. We have 0.1. You can have also the ionic strength here. There's the ionic strength. Then you can have these activity coefficients for NaCl. So what will be the value here? Okay, then you can repeat for 0.1 molar, 0.05, and so on. So you need to have also a table for another type, for another electrolyte. You can have also for CaCl2, repeat. You can also have for another one is sodium sulfate. And last one actually here would be potassium nitrate. Okay, so once actually you have this table, you need to plot a graph. Okay, so the last part will be, so this graph for concentrations. Okay, and then this will be activity coefficients. So you see for NaCl, so you plot the graph based on this table. This against of this concentration and plot. You will see here what would be the trend for NaCl, what would be the trend for CaCl2, okay, and also here would be potassium nitrate and also sodium sulfate. Okay, once you see the trend, then you need to discuss the trend and why. Okay, so how can you discuss scientifically on this result? Then after that, you can come with the conclusions. The conclusion must basically reflect your objective, right? So you need to conclude based on these three objectives. And don't forget also to put your discussions, any errors, okay, if you found errors, and also any precaution step in this experiment. I think that's all from me. If any questions, please actually you can ask me on this report.